I mean, people often think that this has sort of come out of nowhere, but actually it's been a kind of steady march over 15 years of continuous improvement year after year, focusing on the same few objectives: more data, more compute, larger training runs, and really the same core architecture, this same idea that you can represent complex ideas with neural networks and they can be good for prediction has turned out to be true. This has been proven out. This is the kind of core thesis of DeepMind, and then many other companies now have been pursuing it for a long time. I think the crazy thing is that it's really working now. You know, it is genuinely a general purpose, very effective way to predict pretty much anything in very complex environments. And prediction is the primary skill of intelligence. You know, it's the main thing that makes us special as a species. We're very good at guessing what might happen and then using that guess to creatively intervene, whether we're manufacturing something physical, or we're writing software, or we're talking with one another, or playing a sports game. It's a very fundamental skill. So yeah, I mean, it feels like a very creative and fun time to be using this new tool that everyone gets access to. When you look back, it's obvious what the inflection points were. The first, I mean, it depends how far back you want to go. I mean, AlphaGo was clearly an inflection point. I mean, that was, although almost a decade ago now, that was really the first large-scale application of GPUs. So, we hadn't really fully connected individual GPUs in that way before. And it was one of the things that really gave Jensen an inspiration that he was on the right path. I mean, Jensen is incredibly visionary, and he has been betting on GPUs since, as early as 2012, when he saw the cat neuron paper in deep learning. This was the first time that somebody at YouTube used a neural network to recognize cats in videos. One of my colleagues, actually, Andrew Ng, who's actually the founder of Coursera, and an amazing teacher of machine learning. That was really an indication that you need these very large parallel computers, that can run, thousands or now trillions of operations per second in parallel, in order to search for the right combination of pixels that correspond to a cat versus a dog versus a zebra. And then there's a series of breakthroughs like that along the way that gave everybody an insight that actually the same core method is working, and it's just scaling. So it's often referred to as the scaling laws, how to kind of scale up more and more compute with more data to improve our predictions. And then I think most recently, the things that blow me away are the quality of the voice models. Can generate new audio in real time, so it feels like you're having a conversation. I mean, it's just a mind-blowing thing. I mean, it's sometimes you see a piece of technology sort of grow over a long period of time, and even though you're very close to it, you're still surprised when it works so seamlessly and it becomes second nature. And then you take it for granted, and then everyone thinks it's not interesting anymore. Like, it's amazing that you have video streaming on your phones, or you have audio recording. That's just amazing to me. We're in this amazing place in the history of science, which is we have more breakthroughs than we know how to apply. We have a technological overhang. We've never had that in human history, where the same breakthrough is just producing more and more applications and more products and more use cases month after month, week after week. That's a great example. There's nothing novel about that. It's just generate a script of two people talking to produce a podcast, and then instead of training one conversational spoken model, just add two, and they take turns. It's kind of amazing. So it shows you that really we are just figuring out all the many ways that this technology can be profound and impactful. It's a very creative time. Definitely. I mean, there's going to be so many, it's going to be an amazing teacher. It's going to give you a personalized curriculum to help you learn whatever, topic of interest you have, whether you're young or old, midlife or not. It's going to be an amazing doctor in the future. It's going to give you medical advice at near zero marginal cost, right? It's going to give you medical coaching and wellness coaching, help you adhere to, stay, to stick to your regime if your doctor has given you a weight loss plan, or you need mental health support and coaching, or you'd like to, go to the gym. It's going to give you creative advice if you're trying to, write an essay or produce a podcast or start a new business or get legal advice. I mean, the use cases are endless, and that's why it's a Copilot, because we see it as a kind of aide, as a consigliere, as a, as something that is really empowering you to be your best self. Memory is the critical piece, because today, every time you go to your AI, you have a new session and it has a little bit of memory for what you talked about last time or maybe the time before. But because it doesn't remember the session 5 times ago or 10 times ago, it's quite a frustrating experience to people, because you don't go and invest deeply and really share a lot and really look to build on what you've talked about previously, because it's going to forget. So you sort of tap out after a while and it turns, into a shallower experience. But we have prototypes that we've been working on that have near infinite memory. And so it just doesn't forget, which is truly transformative. I mean, you talk about inflection points. Memory is clearly an inflection point, because it means that it's worth you investing the time, because everything that you say to it, you're going to get back in a useful way in the future. You will be supported, you will be advised, it will take care of, in time, planning your day and organizing how you sort of live your life. So it's that capability alone, which I expect to come online in 2025, is going to be truly transformative. Yeah, it'll be expensive to begin with, but as we have seen in almost every technology, from the television to the camera, once it's useful and, some people can afford to, give feedback to it and live with it and work with it, then everybody wants it, naturally. And so when everybody wants it, there's the, economics of scale that really drive down the cost. Today, the very best models that we serve on Azure are now 99% cheaper than they were 2 years ago. And that's on Azure. That's like the best platform in the world for accessing these models, right? So I expect that cost curve to come down even more aggressively in the next few years. It's always a kind of strange feedback loop, because as the cost comes down of computation or of the algorithms, then we can use more of it, which means we can create even more complicated, interesting, powerful, creative experiences. So we've been in this cycle for a century now almost of computation, where it gets cheaper, but then we use more of it, and then it gets cheaper and we use more of it. And so we're in this kind of amazing feedback loop where so far more computation always delivers more value, right? It makes it more accurate or easier to control, so it gets more precise. You have stylistic influence and you can shape it to behave in a certain way. And that, I think, is an amazing feedback loop at the moment that we're kind of in, a sort of a beneficial cycle, if you like. Not yet. So, I mean, at the moment, it's most reliable in sort of English, some of the European languages, Spanish. But in time, there's no reason why the long tail of 120 languages in India, or 5,500 dialects, will not be available. Like I think in the next 3, 4, 5 years maximum, because the same method has already proven itself to work in all those other languages. So it's just a question of time and digitization. And you need less and less data. Once the main model is built, you don't need the equivalent amount of data in the long tail of languages, because it sort of bootstraps from the core language. Yeah. So I don't think data is going to be as much of a limitation. Plus, the more people talk to it and use it, even though they don't explicitly give feedback, they are implicitly giving feedback. So if they end a session, then that might be taken as a negative signal, or it might be a positive signal. Or if they say, no, that doesn't make sense, or that's wrong, or we learn from that feedback. So that's why the more people use it, the better it gets. I mean, Copilot is growing like crazy in India. I mean, it's a huge market for us, which we're very excited about. But partly it's because amazing knowledge workers, lots of developers, obviously people who are bilingual by default, or maybe multilingual. And so, they've been very eager to take up, new technologies for a long time, very open-minded, very creative. So yeah, I think that's why it's one of our fastest growing markets. Some of my strongest teams are in this city. Same with Hyderabad. We have very large ads engineering teams. We have large research teams. Some of the biggest impacts that we've had in improving quality of search results for Bing come from here. So this is why I make the time to come visit here, because it's a critical development center for us. So think of it as a conversational companion that you can ask any question anytime in your own style, at your own pace, that has no judgment, never gets frustrated, never gets angry, never gets bored, never gets tired, and is always available to reframe any question or problem you're thinking about to your level, whatever you feel like at that moment. Okay. So it's completely responsive to what you need. Definitely. I mean, we have a huge Copilot for work effort, M365 Copilot, and it helps you redraft emails, helps organize your calendar, helps you, write creative documents in Microsoft Word or use Excel. In time, it's going to be a troubleshooter. So you're at your Windows machine and you get stuck with a setting. Maybe you're trying to change your Bluetooth, or you're trying to fix a bug in your program or something. It's going to be working with you at the same time, saying, no, like, look over here, open that, close that window, organize, it's going to see what you see in real time on your desktop, on your mobile phone. And that's a key transition moment, because today, you have to explicitly communicate to your computer in words or in buttons. Whereas tomorrow, you're just going to make a reference. You're going to say this or that, or look there, or what color is that? What do you think of that? Like, it's going to be like having a companion by your side. And that's a different plane of communication to what we're used to. It's like each new wave of technology opens up a new plane of communication. Radio opened up one-to-many broadcast with audio. TV opened up more than one, but thousands or maybe hundreds of thousands to many, with all the different channels over time. And then the internet opened up all-to-all communication. And so each mode of technology enables you to think and act and talk in a completely different way than what you've done previously. And so that kind of draws out a different part of you. You're going to be able to express ideas that you didn't even really know you had, because there's a new modality at your fingertips. And having an ever-present companion that sees what you see and hears what you hear in real time is going to feel profoundly different. Just as the touchscreen, every time everyone used the touchscreen for the first time, it's a profound difference. The fact that you can swipe around and tap things and drag things. Some kids now, you see, even I do it every now and then. You go to a magazine and I try to pinch and zoom the magazine. I'm like, scrub the map over, and it's like it doesn't move. So you learn a new subconscious way of trying to shape your digital world, because you have a new tool at your disposal. And that's, I think, going to be a big shift. To always have that companion at your disposal to ask a question or to be creative or to be curious, deeply empathetic, yeah.
Really?
But I think more so than humans. I think so. Yeah, I mean, it's conversationally fluent. It's very relaxed. It can handle interruptions. It can be patient when it needs to let you speak. It'll give you active listening. So it'll be like, yeah, cool, you know. Exactly, yeah, exactly. So it's a different way of talking to computers, which is, I think, a huge shift. I mean, 3 years ago, it had no reasoning whatsoever. You just ask a question and it gives you the best answer it can. Today, we now have models where before it gives you the answer, it gives many, many answers to itself in its own head, in its own working memory. And then it tries to rank those answers and say, okay, is this what the user is looking for in this moment? Will it make them bored? Is it answering their question? Is it entertaining? Is it accurate? Okay, yes, all right, produce it. No, okay, let me produce another one that is more like this. So it can do these things called chain of thought. You can think in its own head, which is a form of reasoning. And it can do that many, many, many times, like up to 100 times. Obviously super fast time as well. So it's doing that in a second or, a couple seconds before it produces an answer. It allows the model to reflect on its own answer and evaluate the quality of its answer and iterate that answer before producing the result. So it is like reasoning. You think through a problem step by step. It's quite different to how things have gone before. I think that the important thing is to be open-minded and embrace the possibility, and be multidisciplinary, because the future high-impact individuals are going to be able to speak a range of different technical and social languages and operate at the intersection of disciplines. Specialization is still important, but you have to have specialization and breadth, because we now live in an all-to-all information exchange world. You see many young creators online today, influencers and people in social media. They're good at coding, they're great at using new tools, they're creative, they can use all of the design tools, they can make short films, they're making music. Everyone is becoming multidisciplinary because they're learning from what everybody else is doing almost in real time. So it's almost like the collective intelligence of our human species is taking off. It's getting more and more capable because we all learn from each other in this huge sort of morass of collective intelligence. It's quite remarkable. And that's just from all-to-all connectivity and reducing the barrier to entry to access tools that make us smarter.